This is video 6 of the CISC 132 Routing Protocols and Concepts series. This video will focus on OSPF, and let's go back to the second video after we configured the default gateways on our LANs and our WANs, and we need to configure some routing. And I've taken out all the RIP commands and EIGR commands from the past, so we'll just be starting with OSPF. Now remember, OSPF is a link state protocol. EIGRP was distance vector, and distance vector is route by rumor, because all I'm doing is I'm taking my neighbor's routing table and whatever distance he says it is to get to that far network, and I'm adding the cost between him and me. With link state protocol, the routers actually send out information about the directly connected networks themselves, and that gets flooded throughout the network. So in this case, Granite City will tell Belleville, but Belleville won't update his routing table and then tell Redbud. What will happen is Granite City will tell Belleville about his LANs and his WANs, and then Belleville will immediately pass us on to Redbud. Then both of these routers will then create a mathematical topology of the entire network and be able to create a loop-free, low-cost, direct path to those networks. Now, configuring OSPF is very similar to EIGRP, but there are a couple tweaks. And before I go into configuring, I want to point out that I added a network 1.1.1.0/30 between the Belleville network and our ISP. So this is our enterprise network, and we're now being connected to the outside world. So let's start with configuring Granite City. Oh, and also I've already configured the Belleville router and the Redbud router with OSPF. So once we configure Granite City, we should have full connectivity with the rest of our enterprise network. So the first command is router OSPF, and unlike EIGRP where we have an autonomous system number, in OSPF we just have a process ID, which means absolutely nothing. You may remember in EIGRP that number had to be duplicated throughout the enterprise network. So all the other routers also had to have that autonomous system number. With OSPF, that is not the case. This number is only locally significant. It really doesn't mean anything other than that's the number of the ID. And like in the EIGRP, we also have a network statement. We also have a wildcard mask, which is also very similar to EIGRP. But something else that we have in OSPF is the area number. And this tells the routers which networks belong in which area. That way we can break up our network into smaller pieces. So this is the third interface here. And if I did everything right here, once I hit enter, I should get an adjacency. There we go. With the Belleville router. So if I do a show IP route, I can see all my networks. Now remember, I've already configured Belleville and Redbud. So you can now test this by pinging all the devices that are within our enterprise. So let's try that now. So I will try to ping from that workstation to the email server, and that is now successful. But I want to try to ping maybe outside our network. All right, what if I tried to ping the ISP here? Let's see how successful we are there. That failed. Wonder why that is. Well, let's take a look here. We'll go to the command line, and here's the actual command, ping 1.1.1.2, and it's telling us that the host is unreachable. So 1.62, which is our default gateway, said, hey, look, I don't know how to send it there. Now, the reason that is because Belleville isn't telling anybody about that. So if I do a show IP protocol, I can see that I'm telling everybody about the 192 networks, but I'm not telling anybody about the 1.1. Another good command to troubleshoot with OSPF is show IP OSPF neighbor, and then I can see if I'm actually creating those adjacencies or not. And if I don't have a neighbor, then I know I've probably misconfigured a network statement somewhere or have a bad cable. Okay, so what I need to do is put a static route, a default static route, and push it out to everybody. And this is one of the nice things about OSPF. You may remember the IP route quad 0 command, which is a gateway of last resort for routers. So this is a way of telling my router where to send it to if he doesn't have a specific route. But now, just because my router has a gateway of last resort doesn't mean anybody else does, right? So gateway of last resort is not set. One of the nice things about OSPF is I can now push this default gateway down to everybody else. And that command is default-information originate. Now, when I go down to Grant City, didn't mean to do that. And I do a show IP route. I've lost all my configurations because I disconnected. There we go. Let's try it again. There it is. And now our gateway of last resort is there. So let's try that again. This time I'm going to, instead of going to .2, I'm going to go to do .1, which is on our side of the network. And that's successful. Even though I don't have a specific route here, you see where I don't have a 1.1 network. Because of my gateway of last resort, I can reach that. But watch what happens when I try to ping 1.2 here. And hopefully this will not work. Now the question is, why can I ping this side but I can't ping that side? Well, the answer is that the ISP router gets traffic from 192.168.1.0 network, but he has no idea how to send it back. So, see, he doesn't know about anybody other than that. So what I will do is I will put in a static route to 192.168.1.0, 255.255.255.0, and that is serial 2/0. Now, if I do a show IP route here, I have a way to get to 192.168.1.0. And notice that this is a summary route, and it reaches everybody over on this side. So now we'll try that, see what happens. There we go. So go ahead and configure the routers with OSPF and try this lab. And this should finish OSPF.